Imagine a moment so profound that it could redefine everything we know about existence. Deep beneath the border of Switzerland and France, in a facility that feels like it belongs in a science fiction epic, scientists at CERN, the European Organization for Nuclear Research, are unraveling the mysteries of the cosmos. They're not just chasing theories, they're colliding particles at nearly the speed of light, probing the very fabric of reality. But what happens when humanity dares to explore the unknown? What secrets lie hidden in the subatomic world, and what are the consequences of unlocking them? Today, we're diving into the awe-inspiring work at CERN's Large Hadron Collider, where recent experiments have pushed the boundaries of science and sparked questions about the limits of human curiosity. Stay with us until the end, because the discoveries we're about to explore might just change the way you see the universe and our place in it. To understand the significance of CERN's latest experiments, we need to start with the basics. What is CERN and why does it matter? Founded in 1954, CERN is a global hub for particle physics, bringing together thousands of scientists, engineers, and researchers from over 70 countries. Located near Geneva, Switzerland, it's home to the Large Hadron Collider, LHC, the world's most powerful particle accelerator. This 27-kilometer-long ring, buried 100 meters underground, is designed to smash subatomic particles together at unimaginable speeds, recreating conditions that existed fractions of a second after the Big Bang. Why? To answer fundamental questions about the universe. What is matter made of? Why does it behave the way it does? And what unknown forces or particles might still be out there, waiting to be discovered? The LHC is a marvel of human ingenuity. Protons, accelerated to 99.9999991% the speed of light, collide inside detectors the size of cathedrals, producing showers of particles that are analyzed by supercomputers. These collisions generate temperatures hotter than the core of the sun and energies that haven't existed naturally since the universe was born. It's no exaggeration to say that CERN is peering into the building blocks of reality itself. But with such power comes responsibility and questions. What happens when we push the boundaries too far? Are there forces we're not meant to uncover? Let's explore the science, the discoveries, and the ethical dilemmas that make CERN's work so captivating. Let's take a moment to appreciate the sheer scale of the LHC. This isn't just a machine, it's a testament to human ambition. The collider's 27-kilometer tunnel is lined with 1,232 superconducting magnets, cooled to negative 271.3 degrees Celsius, colder than outer space, using 96 tons of liquid helium. These magnets guide protons around the ring, accelerating them to produce collisions that release energies equivalent to a mosquito hitting a window, but concentrated into a space billions of times smaller. The detectors, like ATLAS and CMS, are technological wonders, capable of capturing millions of particle interactions per second and processing petabytes of data annually. It's like trying to photograph every raindrop in a thunderstorm and then analyzing each one to understand the storm's origin. The LHC's third run, which will continue through 2026, is producing more collisions than ever before, thanks to increased luminosity, a measure of how many particles are smashed together per second. This allows scientists to study rare events that might occur only once in billions of collisions. For example, the LICE experiment is exploring the quark-gluon plasma, a state of matter that existed in the early universe, while the LHCb experiment is investigating why matter dominates over antimatter. These studies aren't just academic. They could reveal why we exist instead of being annihilated by antimatter at the dawn of time. But the LHC's power also sparks curiosity and concern. What happens when we manipulate particles at such extreme energies? Could we accidentally create something dangerous, like a black hole or a new form of matter? These questions, while often exaggerated, deserve a closer look. Let's separate fact from fiction and explore the safety of CERN's experiments. The phrase "playing God" often surfaces in discussions about CERN, especially when experiments push the boundaries of what's possible. It's a phrase that captures both awe and apprehension. Science fiction has fueled fears of particle accelerators creating black holes, opening portals to other dimensions, or destabilizing reality itself. But what does the science say? Let's address these concerns head on, because understanding the facts is crucial to appreciating CERN's work without falling into sensationalism. First, the black hole myth. In the early days of the LHC, some speculated that collisions could create microscopic black holes that might grow and swallow Earth. Physicists, including those at CERN, have thoroughly debunked this. The energies involved in LHC collisions are far lower than those of cosmic rays, high-energy particles from space that strike Earth's atmosphere daily. These cosmic rays, which have been bombarding Earth for billions of years, produce collisions thousands of times more energetic than the LHC, yet no black holes have formed. If black holes were created at the LHC, they would be so tiny and unstable that they'd evaporate instantly due to Hawking radiation, posing no threat. What about other risks, like strangelets, hypothetical particles that could convert normal matter into a strange form? Again, cosmic ray collisions provide a natural precedent. The absence of catastrophic events from these collisions over Earth's history suggests that the LHC's experiments are safe. CERN conducts rigorous safety assessments, reviewed by independent experts, to ensure no plausible risk exists. The 2008 safety report, updated for subsequent runs, concluded that the LHC poses no danger to humanity or the planet. Still, the idea of playing God resonates because it taps into a deeper question. Are there limits to what humanity should explore? This isn't just a scientific issue, it's a philosophical and ethical one. The LHC allows us to manipulate the fundamental components of the universe, recreating conditions that haven't existed since the Big Bang. Some argue this power comes with a responsibility to proceed cautiously, while others see it as humanity's duty to push the boundaries of knowledge. These debates are as old as science itself, echoing concerns raised during the development of nuclear energy or genetic engineering. Let's explore the ethical dimensions of CERN's work and why they matter. The ethics of exploration. Where do we draw the line? Science has always walked a fine line between discovery and responsibility. The ability to split the atom led to both clean energy and devastating weapons. Genetic research offers cures for diseases, but raises questions about modifying life. Particle physics, while less directly applicable to everyday life, isn't immune to these dilemmas. The LHC's experiments, though safe, push us to confront the implications of wielding such power. What are we hoping to achieve, and at what cost? Could our pursuit of knowledge unintentionally alter our understanding of reality in ways we can't predict? One ethical concern is the allocation of resources. The LHC cost approximately $4.75 billion to build, with annual operating costs in the hundreds of millions. Critics argue that these funds could address pressing global issues like poverty or climate change. Supporters counter that fundamental research drives long-term progress, leading to technologies like the World Wide Web, which was invented at CERN in 1989. Medical imaging, cancer treatments, and advanced computing have all benefited from particle physics research. The question becomes, is the pursuit of pure knowledge worth the investment, or should we prioritize immediate practical applications? Another consideration is the unintended consequences of discovery. The Higgs boson, for example, confirmed a key part of the Standard Model. But future discoveries could challenge our understanding of physics in ways that lead to new technologies, or risks. If we uncover new particles or forces, could they be harnessed for energy, communication, or even weaponry? History shows that scientific breakthroughs often have dual uses. The challenge is ensuring that our curiosity doesn't outpace our ability to manage the consequences. These questions don't have easy answers, but they're worth asking. They remind us that science isn't just about facts, it's about the human drive to explore, create, and understand. As we marvel at CERN's achievements, we must also reflect on our role as stewards of knowledge. Let's dive deeper into the latest discoveries and what they mean for the future. As of July 29, 2025, CERN's LHC is producing a wealth of data, building on decades of research. One of the most exciting areas of study is the search for dark matter, which makes up roughly 27% of the universe's mass energy but remains invisible except through its gravitational effects. The LHC is hunting for dark matter particles, such as weakly interacting massive particles, WIMPs. By analyzing collision debris for missing energy, clues that particles escape detection. While no definitive evidence has been found, the data is narrowing the possibilities, guiding theorists toward new models. Another focus is the study of antimatter. The LHCb experiment is investigating why the universe contains more matter than antimatter, a mystery known as baryon asymmetry. Recent results have shown slight differences in how matter and antimatter particles decay, which could point to new physics. These findings, while preliminary, are a step toward understanding why our universe exists as it does. Perhaps the most tantalizing prospect is the search for new physics. The standard model, while robust, has gaps. It doesn't explain why particles have the masses they do, why gravity is so weak, or what dark energy is. Anomalies in recent data, like the B-meson decays mentioned earlier, suggest that something beyond the standard model is at play. Could it be a new force, a new particle, or evidence of extra dimensions? The answers are still emerging, but each collision brings us closer. To keep you hooked, consider this. Every collision in the LHC is a gamble with the unknown. Most produce expected results, but every so often, something unexpected appears. A glitch in the data, a particle that shouldn't exist, or a pattern that defies explanation. These moments are what drive science forward, and they're happening right now at CERN. Let's explore what these discoveries could mean for humanity. The LHC is just the beginning. CERN is already planning the Future Circular Collider, FCC, a proposed 100-kilometer accelerator that would dwarf the LHC in size and power. Slated for potential operation in the 2040s, the FCC could reach energies of 100 tera-electron volts, allowing scientists to probe even deeper into the subatomic world. It could confirm or rule out theories like supersymmetry, explore the nature of the Higgs boson in greater detail, and perhaps uncover entirely new realms of physics. But the future isn't just about bigger machines. Advances in artificial intelligence and quantum computing are revolutionizing how we analyze LHC data. AI algorithms can sift through billions of collisions to identify patterns that humans might miss, while quantum computers could simulate complex particle interactions. These technologies could accelerate discoveries, making the next decade a golden age for particle physics. What does this mean for you? The discoveries at CERN might seem distant, but their impact is closer than you think. The technologies developed for particle physics have already transformed our world. Think MRI machines, cancer therapies, and the internet. Future breakthroughs could lead to new energy sources, advanced materials, or even ways to manipulate gravity. But they also challenge us to think about our place in the universe. Are we ready for the answers we might find? Can we handle the responsibility of reshaping reality? If you've made it this far, you're probably as fascinated by the universe as we are. But there's more to explore, and the story gets even wilder. Imagine a world where we understand dark matter, harness new forces, or even discover that our universe is one of many. These aren't just sci-fi fantasies, they're possibilities being tested at CERN right now. By the end of this journey, you'll see why the work at CERN isn't just about particles. It's about humanity's quest to understand existence itself. Let's take a step back and reflect. The collisions at the LHC are more than scientific experiments. They're a mirror to our curiosity, our ambition, and our fears. They remind us that the universe is vast, complex, and full of surprises. Every discovery brings us closer to answering age-old questions. Why are we here? What is the universe made of? And what happens when we dare to push the boundaries of what's possible? As we wrap up, let's make this personal. Think about the last time you looked up at the stars and wondered what's out there. That sense of awe, that spark of curiosity, it's the same force driving the scientists at CERN. They're not just colliding particles, They're chasing the same questions that have captivated humanity for centuries, and you're part of that journey. By exploring these ideas, you're joining a global community of thinkers, dreamers, and explorers. So, what's next? Keep watching, keep questioning, and keep exploring. The universe is full of mysteries, and CERN is just one piece of the puzzle. Share your thoughts in the comments. What do you think these discoveries mean